Hello, myself Pranita Peneji. I'm from CSC AI and ML. Let's discuss about the regression lines in probability and statistics. What is meant by regression? The dictionary meaning of the word regression is stepping back or going back. Regression is a measure of the average relationship between two or more variables in terms of the original units of the data, and it also attempts to establish the nature of the relationship between the variables, that is, to study the functional relationship between the variables and thereby provide a mechanism for prediction or forecasting. What is meant by regression analysis? The statistical technique of estimating the unknown value of one variable, that is dependent variable, from the known value of other variable, that is independent variable, is called regression analysis. How the typical value of the dependent variable changes when any one of the independent variable is varied, while the other independent variables are held fixed. For example, the effect of a price increases upon demand. For example, the effect of changes in the money supply upon the inflation rate. Factors that are associated with variation in earnings across individuals, occupation, age, experience, educational attainment, motivation, and ability. For the time being, let us restrict attention to a single factor, call it education. Regression analysis with a single explanatory variable is termed as the simple regression. Here we can see that price is a dependent variable, whereas f, that is quantity, is an independent variable. And same like that, sales are dependent variable and f is the independent variable. Also, yield, number of students, earning, weight, and production, all these are dependent variables. Whereas F, that means fertilizer, F in number of students is infrastructure, F means education, F height, F employment, these are all independent variables. Now let's see what is the importance of this regression analysis. Regression analysis helps in three important ways. It provides estimate of values of dependent variables from values of independent variables. It can be extended to two or more variables, which is known as multiple regression. It shows the nature of relationship between two or more variables. Let's see where this regression analysis is used in organization. In the field of business, regression is widely used. Businessmen are interested in predicting the future production, consumption, investment, prices, profits, sales, etc. So, the success of a businessman depends on the correctness of the various estimates that he is required to make. It is also used in sociological study and economic planning to find the projection of population, birth rates, death rates, and etc. Now, here comes the regression lines. What are regression lines? A regression line is a line that best describes the linear relationship between two variables. It is expressed by means of an equation form y equal to a plus bx. The regression equation of x on y is x equal to a plus by, whereas the regression equation of y on x is y equal to a plus bx. Let's go get into deep of regression lines. Regression lines and coefficient of correlation. Perfect positive correlation. The graph is given as x on y and y on x. This is called as perfect positive correlation. And the second one is the perfect negative correlation. Here comes the high degree of positive correlation, and the next one is high degree of negative correlation. This is the low degree of positive correlation, whereas the second one is the low degree of positive correlation. Here, this diagram represents the no correlation. So, using this regression equations, we have two methods for calculating the regression equation. First one is through normal equation and second one through regression coefficient. This is again classified into two methods, that is deviation method from arithmetic mean and deviation method from assumed mean. Let's get into detail of these methods. First one is through normal equation. Least square method. Regression equation of x on y is given as x equal to a plus by, where x is dependent variable and y is the independent variable. The regression equation of y on x is y equal to a plus bx. Here y is dependent variable and x is the independent variable. The values of a and b in the above equations are found by the method of least square references. Values of a and b are found with the help of normal equations given below. For the first equation, for regression equation of x on y, we have summation of x is equals to na plus b into summation of y. And second equation is summation of xy equal to summation of a equal to a into summation of y plus b into summation of y square. Whereas for the regression equation of y on x, we can solve it through summation of y is equals to n into a plus b into summation of x. And another equation is summation of xy is equals to a into summation of x plus b into summation of x square. Let's see with an example. From the following data, obtain two regression equations using the method of least squares. So we have the following data, x and y. We can tabulate it through x has some values, finding it the summation, and y will find the summation, then calculate xy and find the summation, then x square and then y square and finding the summation of them. Now substituting them in the equations, summation of y is equals to n into a plus b into summation of x, and summation of xy equal to a into summation of x plus b into summation of x square. After substituting by solving the equations, we get a is equals to 0.66 and b is equals to 1.07. So after putting these values in the equation, regression equation y on x, we get the y is equals to 0.66 plus 1.07x. Like this, we can solve the regression lines. To find the regression equation x on y. Before is the we found regression equation y on x. Now we can find in the similar manner regression equation of x on y using the normal equations. Summation of x equal to n into a plus b into sigma summation of y, and the second equation is summation of xy is equals to a into summation of y plus b into summation of y square. Substituting the values in the equations, we get 24 equal to 5a plus 29b and 168 equals to 29a plus 207b. So solving these both equations, we get a is equal to 0.49 and b is equal to 0.74. Substituting these equations in the regression equation of x on y, we get x is equals to 0.49 plus 0.74y. So this is called the least square method. Now through regression coefficient. In this, we have deviation from the arithmetic mean method. Let's see what is that method. The calculation by the least square method are quite difficult when the values of x and y are so large. So the work can be simplified by using this method. The formula for the calculating regression equations by this method are regression equation of x on y, that is x minus x bar is equals to bxy of y minus y bar. Again, regression equation for y on x is y minus y bar is equals to byx into x minus x bar, where bxy and byx are regression coefficient. That is, we can write bxy as summation of xy by summation of y square and byx as summation of xy by summation of y square. Now let's see with an example. From the same data, let's find it through a deviation from the arithmetic mean method. So we'll calculate the summation of x, summation of y, and the x bar is the mean of x, that is summation of x by number of observations, and y bar is the summation of y, that is y bar is the mean of y, that is summation of y by the number of observation. We get a summation of x bar, summation of y bar, and then x square, y square, their summation, and then sigma summation of xy. Substituting all this in the equations, we get x is equals to 0.49 plus 0.74y. Whereas for the regression equation of y on x, we get y is equal to 0.66 plus 1.076. So we get y is equals to 0.66 plus 1.07 into x. It would be observed that these regression equations are same as those obtained by the direct method. Now let's see what is second method, that is deviation from assumed mean method. When actual mean of x and y variables are in fractions, the calculations can be simplified by taking the deviations from the assumed mean. The regression equation of x on y is x minus x bar is equals to bxy into y minus y bar. The regression equation y on x is y minus y bar into b of xy into x minus x bar. But here, the values bxy and byx will be calculated from the following formulas, that is, bxy is equals to n into summation of dx into dy minus summation of dx into summation of dy by n into summation of d square minus summation of dy whole square. And whereas byx will be given as n into summation of dx into dy minus summation of dx into summation of dy by n into summation of dx square minus summation of dx whole square. Let's understand this method using the same example. So we have this data and we are assuming 7 as the mean of x series and 6 as the mean of y series. Now finding the summation of x and summation of y, and deviation from assuming that is 7, we find dx values as x minus 7 and finding summation of dx, and then dx square and finding the summation of dx square. And now we find deviation from assumed mean of y series, that is 6. So finding dy, we get summation of dy, then dy square, we get the summation of dy square, and then finding dx into dy, we get summation of dx dy. Let's substitute them in the following formulas. The regression coefficient of x on y will get bxy as 0.74. Then we can write the regression equation of x on y as x is equals to 0.74y plus 0.49. Same like regression coefficient of x on y, we can also write regression coefficient of y on x. So here we get byx is equals to 1.07. Now we can write the regression equation y on x as y is equals to 1.07x plus 0.66. It would be observed that the three regression equations are same as those obtained in least square method and deviation from arithmetic mean. Thank you.